In the last class, if you recall, we said we will talk about some of these leak sources, why PSM is important. No problem, please come. Some of the leak sources which are important, and we also basically talked, but not in detail, on the difference between safety and PSM, normal safety and PSM. I hope you have some understanding on that. So from now on, what I will try to go about is that to introduce some more concepts on what exactly is PSM. When you go into the factory level, when they say PSM, what exactly they mean by PSM, and I will not touch all the elements of PSM, but then few things on say like QRA or what is our lab principles, that I will take you through today and tomorrow. Okay. This is typically of a refinery where you will find that so many kilometers of pipe network and other things are there. Now, in addition to this inventory of leak sources, what is missing here? This is all hardware part of it, correct? Pipe work, flanges, then you have valves, compressors and other things. The other two things which we play around and which we know don't have much grip is on the software part of it, because there is a software linking all these things that yes, we have evolved, but we cannot always say that we have mastered the way we are controlling the reactions. Then the third most important thing which we have not mastered at all is what? Is nothing but humans. So we don't know when someone will behave in a correct way, will not behave in correct way, why he will press a valve, why he won't respond, because the research that is going on is to see how do we minimize the alarms in a control room. So you will find that lot of times lot of alarms coming in. So when a normal person enters, you wonder why he is not responding, so many alarms, but actually in reality lot of it is information. So a person who is there will normally don't react, and or he may press acceptance and then he may react to some. So it is a big science by itself, alarm management. So what I have shown here you is only a hardware part of it. The other thing is there is always a relationship. See, as they say, everything does not happen all of a sudden. Even a catastrophic failure, suppose a 12 mm thickness vessel is there, if it has to have a hole, slowly the thickness has to reduce. Otherwise, okay, some external object impinging on it making a hole is different, but if it has to fail on its own, over a period of time it gradually reduces because of corrosion or misuse or wrong products being fed into that, then slowly the thickness reduces. So we do not notice that suddenly it fails. So in the same way, there is a theory that for every one incident there will be 600 incidents or 600 kind of happenings which will give a prior notice that something major is going to happen, or the ratio is that for every 600 no visible loss incidents there is going to be one major injury. That is what the reality, that is what the equations that say in the factory with respect to injuries. That means if somebody has to break his or broken his hand or leg or something, before that there will be so many incidents, but people will not notice that this is happening, it is kind of a near miss, and then ultimately one big incident happens. This was a long time back, a study was done and all that, but in process safety unfortunately the ratio is not so large. So every 11 process incidents can result in a fatality. I hope you understand the difference. Okay. Now there are a lot of research is going on what is meant by process defect. Means if a safety relief valve pops up, is it an incident? Because it just popped up, pressure is more, it popped up and then again sat back, right. If it continuously it is happening, then do we need to investigate? Is it an incident? So today there is no mechanism or there is no way that we are capturing those process related incidents. So that is where the trick lies. If the research is going on how do we capture those process defects. Process defects, again you need to define what exactly you mean by process defect. If 1 kilogram of something coming out of a war flow, can it be called as a process defect? Can it be failure of some XYZ mechanism? Is something where that we need to look at it. So, I hope you are able to get the relationship between the both. In process safety, the ratio is between 11:1. In case of industrial safety, normal safety, the ratio is anywhere between 300 to 600 to 1. So, this is the major difference that you find, that is the reason you find that we need to concentrate more on the process safety area. Now, what could have prevented these incidents from happening is something that question will ask. So, just being aware about process safety, will it produce those results, or we need to do something more, is something that is important. So, there is a joke which goes and says, this is what the first block you can see, that is what the client ordered, but by the time the client explained and the designer built and then it was conceived, and what was finally delivered was the something different. So, you can see what the client ordered is a simple climbing tool. How the project manager understood, how it was planned by the engineer, and how it was implemented by the technician, and how the consultant interpreted it. So, this is how the things will change. So, every time when a designer designs things, everyone will have their own imagination to implement things, then in the process something else happens. So, in process safety also you will find that this kind of things that finally happen, and the design many times it fails. So, there is a broad definition of what is process safety management. I hope this was not covered earlier, correct? Covered? No. So, what is process safety management? What it says, proactive and systematic identification, evaluation and mitigation or prevention of chemical releases that could occur as a result of failures in process, procedures or equipment. So, broadly what it is saying, process means your hardware part of it, say what temperature, pressure and other things. Procedures is your software part of it, SOP, safe operating procedures, or how do we run the plant kind of thing, and equipment. So, what can result in a chemical release? So, the point that need to be noted here is that process safety management quietly evolved as a result of major disasters in chemical industry. But now the trend is, of course, the process safety management is getting applied even to the engineering industry, even to the oil and gas, even to the steel also it is getting introduced. So, because what they said is process safety management talks about proactive and systematic identification and evaluation and mitigation of process, procedures or equipment. So, all the three things are there even in steel plant. And if you look at some of the steel plants, the blast furnace gas, there is a big gas handling is there. They also generate oxygen in a big way. They also handle molten metal in a big way, which has lot of what I would say properties and lot of chances for big incidents to happen. So, in broad what they are saying, process safety is a blend of engineering and management skills focused on preventing catastrophic accidents, particularly explosion, fires and toxic releases associated with the use of chemicals and petroleum products. So, if you recall, I differentiated between normal safety incident and process safety incident as what? Do you remember those two words? What are the two words I talked about? Anyway, difficult to remember, I will give you a hint. One is probability and severity, right? In PSM, what is how the probability severity are linked? Probability is low, severity is high. In safety incidents, probability is high and severity is low. That 600:1, 11:1. So, that is what we are saying, that catastrophic accidents means we are saying that where the severity is quite large. We are not talking about small one cage vessel rupture or anything. We are talking about big releases, big incidents which can have lot of loss of lives and property. See, actually after the Bhopal gas tragedy, lot of work has started working in PSM, because one thing that was felt is that normal safety systems are not able to predict this kind of major accident. So, there should be something more that need to be done. So, we will come to the elements part of it, then you can see in the elements you will find lot of elements look very simple, and you will wonder why PSM gives a different color, but the way it is applied is something which makes a difference. So, the goal, that is the fourth line, that is important. The goal is to minimize process incidents by evaluating the whole process. So, a holistic approach to process management is what is making it different from the other approaches of controlling major releases. So, this is again what happened is, as the definition of process safety propagated to other disciplines like electrical, electronics and other things, each of them came out with this their own interpretations and definition. This is IEC International Electrochemical Commission 61511, which is talking about functional safety, which some other lectures will talk about. They have defined risk arising from the process condition caused by abnormal events, including basic process control system malfunction. So, they were talking about DCS systems. So, because the system is not functioning properly, I think you have seen that video of Texas PP refinery, where you have seen that the basic measurement was not proper, and it was filled for more level than what is the instrument can gauge and all that. So, they are relating it with abnormal conditions that can happen because the process conditions are not correctly controlled. Then the risk existing for specified hazardous process events for the process, the basic process control system and associated human factor issues, a function of the risk associated with the process itself, but takes into account the risk reduction brought about by the process control system. See, what happens is, when you broadly define the risk, everyone will ask, okay, so we have this control system. If this control system fails, then we have a some other containment system. Even if this containment system is having some problem, then we have other control system to mitigate the risk. Then why we should look at worry so much. So, what in process safety, what happens when you systematically evaluate the various risks, you will also give credit to the existing risk control measures, right. Say, I will make it very simple. Say, suppose this building is there. What can go wrong in this studio? It can catch fire. Now, if it catches fire, then what happens? Everything gets destroyed, right. So, what is the basic control measure that is there? Fire extinguisher is after the fire starts, but first detecting that there is a fire. So, you will find some smoke detectors and other things. So, that is the fundamental thing that you detect, that is one level of control. So, the idea is what? If you detect a fire, then your fire extinguisher will come into picture, which you will go out and bring it inside and then fight the fire, because any fire will start in a incipient way and then goes on to become something very big, correct. So, then if that fails, like your extinguisher has failed, then what else can be done? The building will have either, okay, in this flow you do not have sprinkler system, but sometimes the sprinkler system itself will operate. That is the second level. Suppose that also fails, like something happens, then you have hydrant system where the people can apply water and then put out the fire before the thing. So, there the basic assumption is that you will say that somebody who knows how to do firefighting, how to hold a hose, and see they are available and they can come, because you have a large security system and you have trained people within the lab and all that. So, you will try to give credit to all these things, so that you can say the risk which was say in the magnitude of 10, Now, with this kind of layers of protection, yes, it has come down to acceptable risk. Now, how do we further improve? Say you are concerned, still no, I do not want this kind of risk also. I want the risk to be brought to the as low as reasonably practical. That what we are going to talk about further. So, then you will go into detailing what catches fire here. What catches fire here? Wood is there, then wood is there. What else you are saying? Huh? Projector can catch fire. You have cables, then you have false ceiling, right? And you find that plywood kind of things, those boards, yeah, those boards. Then the curtain, plastic. Then you have carpets. Then of course here seats are made of plastic, correct? So is it a way possible to make all these things fire retardant? Yes, you can make it if you spend a little bit more money. You can make all these things fire retardant. You can have what is called FRLS cables, fire retardant low smoke cables. You can convert a ordinary plywood into like this tool or this thing into something fire retardant by applying fire retardant coatings. You will have plastics which are fire retardant. So if you adopt all this, even carpet also you will have fire retardant carpets. Now if you adopt all this, do you think the chances have come down or not? Yes, all of you agree, no? Now what happens, earlier which was 5, now it has come down to, because of this various layers of protection, might have been around 1, but still we cannot never say that it is 0, because something else, like maybe we are not all wearing fire retardant clothing, this can catch fire, okay. Then fire can spread from some other room from there, okay. Then there could be so many other things, but so we will never declare that this is risk free, but we have done something which is as low as reasonably practical. So the concept here what is saying is the function of risk associated with the process itself, but it takes into account the risk reduction brought about by the process control system. It is similar thing like that. Suppose you have a vessel, okay, and you have an exothermic reaction, right. Now what happens if the exothermic reaction is not controlled? Runaway can happen, there could be an explosion and other things. So what kind of process control you would like to adopt? First of all, we would like to adopt say addition itself on a controlled way, right. How does an exothermic reaction happens when you have two chemicals added together? So control is 1. So then second thing is, okay, then somebody may argue that yes, addition can be faster, or the valve has malfunctioned, so more thing is getting added, so the pressure is getting developed. So what we will have, we will provide a relief. We may provide a rupture disc, or we may provide a relief, or whatever it is, right. So then not to reach that stage, then we will measure the temperature, measure pressure, or we may have a dump tank if the reaction is very, very explosive, so that when the certain pressure reaches, then we will say that this dump tank will open and everything this thing falls into the reactor vessel and the reaction is blocked. So we will take into account various risk reduction measures based on the criticality, on the acceptable risk, and try to control this. So that is where they are talking about the process risk. So process risk is a subset of process safety management. So why it is being introduced? This is being introduced to say that process safety principles are now getting applied even to the control points also. It is not just the layout, it is not just the vessel, it is not just the procedures, it is even now getting extended, or rather extended already, to the control systems itself. Now there is a comparison which I already mentioned to you, typically give rise to major accidents, typically give rise to incidents such as injuries and fatalities. So the thing that you need to know here is both the sides fatalities happen, both the sides fatalities happens. It is not that only some slip, trip and fall flow into the personal safety, both sides fatalities can happen, but the severity part will be quite high in the process safety thing. Most of the process, so like the what I would say injury triangle or the safety triangle, they have also constituted what is called process safety triangle. So, the topmost thing when you call it as process safety incident, it will primarily will have lot of primary loss of primary containment. That means you have a vessel, it has come out of the thing, that is the major thing that can happen. Near misses including demands on safety system, plant upsets, flaring, all these things are one level below. Before the loss of primary containment happens, there could be near misses includes demand on safety systems, means in any vessel you will have what kind of, if suppose you it's a say 20 feet vessel, you will not set the, you will not fill the vessel up to 20 feet, up to what level you will fill, maybe 18 feet. So, what you will put there at 18 feet? You will put a alarm, high level alarm, correct, no? Yes or no? Then you will have low level just one step below, then above that you will have high level, right. So, those are all near misses including demands on safety system. You know, your valve or your pump is supposed to close at 17.89, but it has touched 18 and it has triggered. That means there is maybe sediment level is more. There could be so many other things which have resulted in that kind of thing, or the valve is passing, or the maybe defect in the gauge. So, those are all the things which we will talk about near misses including demands on safety system and plant upsets. Flaring is something which is always investigated because it is not from the economy point of view, but you are forced to send it to the flare, right. Flare is nothing but a process upset, then it goes straight to the flare, apart from the normal things that happen. So, whenever flaring happens, that also sometimes it is recorded. Then insufficient operating discipline, example procedures not followed, P&ID is not updated, lack of maintenance. So, these are all bottommost rung. So, before a process safety incident happens, these are all the things that can go wrong, like insufficient operating discipline. What does it mean? Because for every operating plant you have something called operating parameters. The operator is supposed to follow that rule book, but supposing he does not follow, then it is operation discipline is not there. Then procedures not followed means he has to follow certain procedures of loading, unloading, maintaining pressure, temperature and all, but over a period of time what happens, we develop so much confidence on the process, then we know okay, this is the shortcut to do, or this is the way we do. So, that results in the procedures not followed. P&ID is not updated is process and instrumentation diagrams, you may modify changes, but then you do not modify that in the as built drawings. So, that can result in that. Then lack of maintenance, you know, okay, you need to look at the maintenance of equipment, but then you say giving priority to the production, then that results in this thing. So, from bottommost if you see, you do not do insufficient operating discipline, you do not follow the procedures which can lead to near misses including demands on safety system, which can result in loss of primary containment and finally leading to process safety incident. So, that is how the sequence follows. So, now I hope you understand the numbers. So, if this is 11, this is 1. So, that is how the linkage will happen. So, what I am trying to say is that a process safety incident just like that does not happen. It has resulted in process safety incident because all these things are happening at the bottom. Now, there are some myths because PSM, to be very honest, in India is not yet accepted. I would say still a handful of companies are only following PSM because of variety of reasons. One is lack of understanding, lack of expertise, and third is that we also have insufficient knowledge on some of these things. And fourth or rather fifth important point we should keep in mind is that our legislation does not mandate PSM yet. So, we are all legislation driven people, you know, we do not follow certain things because it is required to be followed or it is good practices to follow. We are still, you know, quote unquote, we still think that something needs to be done because the government said or because we need to do. So, PSM is not yet mandatory. So, some of the myths associated with PSM is, lot of people think that it is a performance based approach, or we should also think that one approach is do whatever it takes on your facility not to have accidents. Some people think like that. No people, no PSM. An analytical tool focused on preventing release of highly hazardous chemicals, and some people have a misconception PSM deals with trips and falls. Other most important thing is contractor exempted from PSM, because if you see some of the factories now, except the core operations, the rest is all run by contractors. Even the public sector undertakings, you can find that a lot of things are run by the contractors. So, you can't differentiate contractors from the main operators. So, contractors are also required to follow this thing. So, a typical PSM, for example, we can say to you a typical valve, if you follow PSM processes, so many things we talk about when in the maintenance. So, this you will not find in the normal approach to safety management. When you follow PSM only, you will do that. Now, it will talk about, you see insulation healthiness, right. Insulation healthiness is a big topic by itself. How do you measure healthiness? Because it is all closed, right. One easy way of measuring insulation healthiness is doing thermography, right. When you do thermography, it gives a profile of how the insulation, whether it is a uniformly the temperature gradient is there, or wherever insulation weakness is there, you will find that the temperature gradient is showing more. Then how the bellows are there, and how small bore piping is being done, expansion of liquids in pipes. So, what happens is that, and the other most important thing which is neglected in 9 out of 10 companies is hose management. You will have lot of places unloading hoses, you have lot of places connections, but nobody has a clue on hose management. So, PSM, while it talks about minimizing the incidents arising out of failures of all this, ask the crucial questions, how you are doing hose management in your company. You will find that no answers will be forthcoming. Most of it is that we replace hoses when they fail. We do not check for hydraulic pressure, we do not check for whatever what I would say, that periodic inspection, we do not check for compatibility, lot of things can happen because of that. Okay. Just to give an understanding, further understanding, how does an indicator look like? In a personal safety program, when you are taking up, you will talk about first aid, how many first aid cases. You will talk about hours lost to injuries, how many, I think Factories Act and all, you might have heard about last time injuries and all that. So, those things will be talked about, and recorded incidents that could have resulted in personal injury, exposure due to improper non-use of PPEs. These are the things that will be talked about. But when same company, when it talks about process safety, it will talk about number of failure of critical equipment, because you will have a plant, not everything is critical equipment. So, there are some things which you need to monitor very closely, like ammonia compressor, or cooling water circuit for a ethylene cracker. Those are the critical equipment. So, you will see the number of failure of critical equipment, incidents of loss of containments, right. Earlier days we were in the safety, when we are talking about only safety, we never talked about if something leaks. We used to take it as slip and fall, trip and fall, because something is leaking kind of thing. We never asked a question, why this leak has happened, it is 1 kg or 5 kg or 10 kg, and is there a further, it is trying to indicate to us, is there anything wrong. Then fires, exposures caused by process failures, exposure caused by process failures. See, that means if there is a sudden release of a toxic chemical, right, from the process plant. So, we are asking record it, it is an incident, it is a process safety incident. Do not treat it as the guys are not wearing a PPE and thereby it caused an incident or accident. We are saying that exposure caused by process failure is something which need to be separately indicated. So, I will show you more of that. So, what happens is that the underlying point what I am trying to say is that we may do so many things, we may think through the process, we may review the drawings, we may do the safety engineering studies, we may install so many things, but sometimes and we feel that we have done everything right, but still incidents like this can happen. Agreed? Correct? So, it is a bark which is there for long and it is just passing through, but still it can happen, it can fall at the same time and then it can result. So, it is like, as I told you in the first class, it is like a football goal. You may have a goalkeeper, you may have so many defenders, but then goal will be scored from some angle or other. So, only thing what we are trying to do by all this is that we are changing the probability for the better. So, quickly before we go into some more topics of PSM, I thought I should take you through couple of case studies. This is one thing which again after doing so many things, a major incident happened in Jaipur. Why I am citing this case is that this is one of the big incidents that happened in the recent past, it is in 2009. Now, if you relate this, those of you who are interested can download a small report, it is called MB Lal committee report. Dipin, you can please circulate it to the participants, it is available online. If you do not get, you ask me. It is a small document about 29 or 30 pages. I ask you to, I urge you to read that. So, this is after the incident. Now, after this incident, lot of things in changes in Indian oil and gas industry, lot of studies, new standards, OSD is working on some more criteria. So, if you look at it, it is a big and also it triggered a big debate in the media and in the government circles, because a lot of factories you started some 20 years 30 years back, but the cities have moved towards it. Now, you have lot of neighborhoods to this. Now, you can always argue in both ways, right, city has developed, so these guys have gone there and these guys should have moved somewhere, or they should have installed latest equipment, so that they have taken the risk into consideration. But both things have not happened. The public have not bothered about staying very close to hazardous industry. The industry also has not upgraded its facilities so as to mitigate the risk. So, the end result is what? One incident like this has happened, where 11 persons were killed, 45 persons were injured, and apart from that, I think it is one of the highest what I would say insurance loss ever happened in the Indian insurance industry. I think close to, if I am right, close to 500 crores was paid as the compensation or the loss suffered by the IOCL for this. Now, not only that, because of this incident, IOCL could not place its insurance cover for a number of months in the international market, because everyone said, oh, you have such a large potential, your safety record is so bad, and you see the kind of loss that has happened. So, it was a bad publicity to the company. Why? Because you see here, how many days the fire? 11 days. Finally, they decided, they allowed it to burn because they could not find a technology to contain it. Now, you understand the importance of PSM. We think that we can put off, but before this kind of forces like fire, wind and natural calamities, whatever we have designed is not able to withstand. Now, if you look at the genesis of this incident, leakage from MS tank valve resulted in leakage for 75 minutes. Now, what kind of questions come to your mind when you read this point? What is immediate thought? Somebody says it leaked for 75 minutes. What is your immediate thought?
Why they didn't check it before?
no, why it was not discovered, correct? When you say checked means you are saying why you have allowed it to leak for 75 minutes before you realize that oh it leaked, correct? That question comes to your mind or not? Yeah. Sensor might have gone wrong. What if sensor is not there at all? Both the cases are possible. Okay, sensor has not gone wrong means either it is maintained, not maintained, or is not in a place where the leak has occurred, correct? See, sometimes the expansion happens and then you only expand the tank but you do not expand the safety systems. Okay. Then other question is why the fire was allowed to grow into that big, means our emergency response, because any fire will, it started with leak and then some source of ignition and then it resulted in fire, but we were not able to control. Actually the fire intensity was so much 750 meters from this depot, the ground temperature was 53 degrees. So you can imagine the kind of heat that it got generated. Finally they decided that they can't fight this fire and they allowed it to burn, because there is no technology to put out fires of that. So they tried to allow it to burn it in a controlled way so that it won't have a catastrophic explosion. Similar way now, okay, one incident, this is 2009. Okay. Before that there was one more incident of similar nature but not in our country, in UK, similar kind of thing, more or less in 2005, similar overflow, leak, and you can see here overflow at 550 meter cube per hour is the pumping rate. So imagine that you pump it at that rate for more than half an hour, how much quantity would have come out. Now both these incidents, why I am sharing is that both these incidents have triggered off a mass of debate in controlling authorities, designers, safety engineers, then environmentalists, everyone on how do we treat some of these things. Okay. And also people started questioning that when we have so many systems, how do we ensure that the system does not fail, because you are putting together a lot of systems. You are saying that a valve should be there should be a detector, and then there is a overflow mechanism, then there is a control room and all that, but all these things are failing, and then you have massive releases like this, which is shaking the confidence of people in having this kind of facilities of that large nature. So these two incidents, if you look at it, it resulted in lot of legislation across the world after the incidents. In case of the Jaipur incident, after the MB Lal committee report, all the oil installations, means oil depots, which are numbering around 1500, were asked to do safety studies like QRA, HAZOP and other things, and also go for safety integrated level instruments of level 3 or level 4. So even after say 5 years now, 5 or 6 years now, I would say that only 10% of the installations were able to do complete studies and then implement or do number of things. So it takes a long process. It's not that oh I wish and I replace the valve and then it becomes the safety level raises up. So it takes a lot of time for these things to move up. So this is one, I hope you are aware of this graph. Okay, I think you were asked about major incidents and then the link with the legislation. So you can see here that Flixborough incident, some appreciation about process safety, Seveso, then active control of process safety. Bhopal incident, you will find that Center for Chemical Process Safety has been formed, guidelines like API 750 has been released. Then OSHA came out with its own PSM standard. Then after the BP Texas incident, Seveso directive has come. Then in 2008 risk based PSM matrix have come. So as it is happening, more incidents are happening, you will find that the PSM process is evolving. I would say still PSM is a continuous step in the continuous process that is happening. So, one of the things, yeah, okay, okay, yeah. So, we are continuing up to 6 o'clock. Okay, right. So, if you look at the PSM standard and then what is the purpose? The purpose is the requirements of preventing or minimizing the consequences of catastrophic release of chemicals that are toxic, reactive, flammable, explosive, because there are so many chemicals in this world, right. There is a rough estimate that more than 3000 chemicals are there. Now, there are two things that are important. Even if our body also has got lot of chemicals inside for digestive process, maintaining the balance, imbalance and all that, right. So, there cannot be standards on regulating these things. So, we need to define what is applicable to us, otherwise PSM standard will be applicable to our body also, correct. So, we are saying here is that PSM standard does not mean it is a prescriptive kind of thing, it gives broadly the outlines and leaves it to you on drawing up of what is the processes that needs to you need to adopt. So, what is a performance based standard is something which is being shown here. Focus on what must be done rather than how it should be done. So, they will say you adopt a PSM standard, these should be the elements. You can add more elements, or you can say that these elements I will focus in my company, or these elements I do not focus. It will not say that this is how does success look like, that is very important. The difference between performance based and the more traditional prescriptive standard is that performance based standard concentrate on the result, while prescriptive standard set out the details of the process which may or may not achieve the desired result. Like for example, okay, the spacing between two detectors should be 750 mm, something like that they will say, but whether it will really prevent the fire or not, nobody can say, because there are so many variants. Whereas in the PSM, which is performance standard, it broadly says that if this is the risk, go for detectors. The design part of it does not talk about. I hope you understand the difference between the both of them. These are the various elements of PSM. So, what does PSM finally is now only coming? These are the elements of PSM. It talks about employee participation, process safety information, process hazard analysis, operating procedures, training, contractor safety, pre-startup safety review, mechanical integrity, hot work permits, management of change, incident investigation, emergency planning, compliance safety audits and trade secrets. Okay. Now, in these things the most important things for a chemical engineers are process hazard analysis. That is where the rest of the classes, if you see the syllabus and other things, because the most important thing is the process hazard analysis, PHA. The various safety engineering techniques you use, I will show you little later, there are more than my count is little old, but my guess now is that about 50 different techniques are there in safety engineering itself. So, each of these techniques will identify the process hazard in different ways. No one technique can identify all the hazards that are there. Okay. Then these are all related. Then the other important thing you need to concentrate, or if you want to become a PSM engineer, is the mechanical integrity. Now, mechanical integrity means it is all about how do we ensure optimal performance from the machinery that what we have, as simple as that. Now, there is a big program, and each of the issues with respect to mechanical integrity and the PSM part of it is the most interesting part in the thing, because you will find routinely that this is what the breach that happens in the plants, which can result in failure of the various equipment, resulting in major losses. Then of course, the next in the line of importance is contractor safety. Pre-startup safety review is that when the plant is all built and you are about to take the chemicals in, then you see whether what you are designed is actually there in the field or not. So, you may ask, can it happen like that? Yes, it will happen. In the pre-startup safety review, lots of issues will come up, and I will share with you how in a refinery that we found more than 160 points which are related with process safety when we did a pre-startup safety review. Lot of points will be assumed that it will be done in such a fashion, but it won't, then which results in a kind of, you need to take a call whether you need to start up today or you won't start up. I will give you a simple example. Recently it happened in one of the process plants. There is a compressor. Okay. Now, compressor tripping mechanism says that you have two sensors and you have 3 sensors, 2 out of 3 sensors have to say that there is a fault. So, it is called what then? 2 out of 3 voting, correct? 2 out of 3 voting, when it is there, yes, now the compressor has to trip. Now, what happened? It is an imported compressor. One of the sensors while transportation, what happened we do not know, but it stopped working. So, the plant has asked for a deviation. So, can we go for 1 out of 2 voting, right? They just want to change the software, that can we go for 1 out of 2 voting. This is a temporary, but they have not defined temporary means what? Means it will be 3 months, it could be 6 months, it could be 1 year. Now, the choice for you, that is coming up in pre-startup safety review. So, they said plant is ready to be commissioned, but the logic now has changed. It is 1 out of 2. So, is it okay to say okay, or should we discuss more? What is your opinion? That is easy to say, correct, but lot of it is kind of a proprietary kind of thing, and it will take its own sweet time, right. One is our process, second is their process, correct. If it is something ready, stock is there, then you can always do that. But what I am saying, pre-startup safety review means plant is yet to start, that means it is a brand new plant. So, you will not have spares for everything, maybe over a period of time you will build that. Okay. Your supplier says that it will take some time, that some time is 3 months or it could be 6 months. So, how do we decide on this? Is it okay to change the logic? No means then the plant is going to stop. So, the way out, what we normally say when you have that kind of issues, then this element comes into change, this comes into picture. What does it element talk about? Management of change. Is it comes under management of change? Yes or no? Yes, no? From 3 to 2 we are changing 1 to 2. So, the process for when you can change, when you cannot change is defined by the management of change process. So, if you are this element you are not strong, then what happens? Few people will argue for a change, you will go ahead for change, and tomorrow if the compressor fails, then what manufacturer will say? You never asked me, you only said one sensor has gone fault, I never asked you to go ahead and do that, right. So, the production, the project people will always press for startup, because for them deadlines, for them project completion or all that will be there. They will hand over the project and go away, but the operating people, they will be left with something which does not work or it fails, so they have to be answerable. So, management of change is something which talks about that. So, we have talked about process hazard analysis for you to focus on, mechanical integrity, management of change, then to an extent contractor safety is also very important, because all said and done you may say that oh, their integration is proper, we have done induction, we have done XYZ and all that, but then contractor is little distance from the normal person, and then sometimes they come for only temporary thing and they may not understand the philosophy of the way you are operating, that can result in major incidents. So, and also if you look at the major incidents that have happened, it all more or less involved the contractors. So, that is the reason why in the PSM the contractor safety as an element has been brought. So, this is how the link that is there, okay, between the various elements. You can see here process safety information is something which is a kind of a link between all the elements, and compliance audits which is sitting on the top. For everything you do, you need to comply with something, so which can result in this thing. Okay, there are some exemptions, like it is not applied to retail facilities or remote facilities, some things like that, but otherwise it can be applied to anything. Now, we will discuss a little bit more about some of these elements before we go into what I would say some things on QRA, okay, basic understanding. Anyway, there is a separate class on QRA which you will be using the software and other things. Now, process safety information is something which is very critical and very difficult to assemble, especially in the old plants, because they will have lost records. Lot of it is done because it is done that way, and then nobody will have a clue on this process safety information. So, the written information should be on hazards of the process, technology of the process, and the equipment in the process. This you may appear very simple, but I will cite from a investigation which we have done about 3 or 4 years back. It is a very simple process, but it has all the elements of all the things that I am talking about here. So, this plant located south of Chennai was in operation for more than 25 years. Okay. It is a simple process. They take they mine the sand and the ore from a beach, and they put it in a big you should imagine a steel vessel of 6 tons, okay, that size, maybe say 2.5 meters by about 1.5 meters. They put this all this thing into that. They add sulfuric acid and rotate it for 5 days. At a pressure they rotate it. Now, after that they cool it, and then they dump the material from bottom and they send it to the further processing. So, do you find that the hazard is there? It is all extracted what I would say mother earth, and to that sulfuric acid is added, that is all, and you do not find fumes, you do not find anything, and it is in operation for 25 years. Now, do you feel safe or unsafe? But I am been handling, I am mixing it with say 6 tons of what I would say, I will take the mother earth and I add some say 500 liters. So, it all disappears into that, and it just rotated at that speed. Operator closes it, comes back after 3 days, 4 days kind of thing. Okay, that kind of vessels are there, some 20. So, at any given point of time one fellow will complete the process. So, they have that work of removing, cleaning the other one and all that, but this is going on for so many years. Okay. Now, one fine morning there was a whiff of release of sulfuric acid. The next thing the operators heard was a big bang, and everyone was kind of taken aback, and the next thing they know that out of the 20 reactors, one was missing. So, they thought what happened, where did it go? So, then they looked at the neighboring plant, means their own shed only. So, no damage to the neighboring plant. That means what? It lifted off vertically, crossed that plant and went off. Actually, it has fallen off 110 meters from the base. This all is the information. So, we have been called in to investigate. Now, why we have been called? They have been operating this plant for 25 years. All the operators are in the range of 50 to 58, and they have spent their whole life in loading, unloading and processing, and they can close their eyes blindfolded and they can do no instruments, nothing. They know by sound and by smell or whatever it is, they know when to close and all. Those instruments and all are old. So, they are not able to fathom out how this can happen, because there is no exothermic. Imagine that you pour sulfuric acid onto the ground, what happens? Some fumes would be there, but beyond that, do you expect an explosion to happen? Okay, they will add steam also into that, but do you expect? So, the information what they were not having is hazards of the process. It was done some 15-20 years back, but today that knowledge is not there. Technology of the process, why 5 days, why that pressure, why that temperature, nobody knew. There is no document now. See, imagine your LKG books are with you? No. Suppose I ask, take out subject number 2, lesson number 3, what did you do, means where is the information? There is no information. Plants, equipment, operators, everything happens like that, over a period of time. The equipment in the process also, so many modifications and all that, if you see all that elements. So, nothing was there in the plant, but for you to do investigation, all that is required. You require a standard operating procedure, you want to know the logic of doing it for 5 days, you want to know what is the reaction kinetics, you want to know what are the process control information, you want to know who decided that this is this the way this vessel will operate, what is the mechanical integrity of the equipment, what pressure it is designed, because it just lifted off, the bolts and everything got sheared off, that is all. Now the evidence is there that it has gone 110 meters and landed within their premises off broken. So, there is a opening. Now, this is the information, but what you are asking all this, they said we do not have, we do not know. We have only have some documents to show how much material we are putting in, how much sulfuric acid, what time, that kind of sheets are only there. Maybe we have to dig archives and do that. So, process safety information is very critical for managing for doing the process hazard analysis, right. This usually starts with the what I would say design. It starts with the design of equipment, consideration of chemicals, consideration of the reactants, from the R&D to the scale up operations, the batch processes, and then the design. Everything will comes into that picture. Technology of the process is also very important. Why you adopted the technology, what are the issues that you have considered while adopting the technology, what were the limitations, why you could not do the latest, is something which is always very interesting. We may think that it is simple, but lot of times the decisions are taken based on the available knowledge. Okay. Then the equipment in the process, how did you select the equipment, what were the limitations, what were the what were the design features the supplier has considered before he supplied, all that is important. So, process safety information forms a key thing in PHA as well as in management of change, because if you are changing something, then definitely you need to know why that is going to affect. Toxicity information, the basic thing, have you ever seen a material safety data sheet? You are all familiar. What is the latest in MSDS, in the sense what it is called now? Are you aware? It is called International Chemical Safety Card or something. European Union has come out with that new thing, which is even more simple than MSDS, because sometimes the MSDS can be very lengthy, 5 pages, 10 pages, difficult to find out information. Now, in India there are standards available, even in Factories Act, in the backside annexure they have given the MSDS information. Basically it talks about the physical reactivity, corrosivity and all that. In our earlier days, when I was young like you, one of the first activities we have done is to prepare MSDS. Even though MSDS for sulfuric acid is there, MSDS for XYZ is there, the process of preparing MSDS exposes to you so many hazards, in the sense makes you familiar with the hazards of various chemicals. Apart from that, our MSDS used to contain information like, lot of MSDS may not give information on PPE to be used, may not give information on the small quantities how to store, big quantities how to store, what are the standards to be adopted for that. Okay. then it may not also contain information on spill control, you know. So, it is not just the physical reactivity corrosivity data, it will should also give other data related with the chemicals, you know, antidotes, you know, that is again very important information. If you do not have antidotes, how do we handle emergencies? Okay. PHA, some part of it it will be talked to you. Here they have only talked about what if, HAZOP, FMEA, FTA, but there are lot of other techniques. I have just wanted to show to you, these are the techniques which I am talking about. There are, if you see 1, 2, 3, 4, 5, 6, 7 different stages of the plant we are talking about. One is at the concept, second is process, design, commissioning, operations, modification and decommissioning. So, that means all the 7 stages of the plant you can use different techniques to understand hazards associated with its operations. So, this is one you can see here. Now, how many Chola MS risk offers in this is, I would not say even 15-20%, right. There are, this is again little old, I would say dates back at least 3 years. Now, in this at least as I know 7 or 8 more studies have been added up. So, if somebody wants to specialize in the area of PSM, I am not saying that he should be familiar with all that, because by the time he gets familiar then he can retire. So, he should have at least familiarity with 4 or 5 techniques minimum, means professional level. So, that is where the it helps you or improves your knowledge. So, the idea is that to show you to show this slide is that each of the stages of the plant you can apply different techniques to get more information about the hazards associated with those operations. Hope it is clear, right. So, at this point of time it is enough for you to know that these are the techniques that are available. My favorite technique is always about the inherent safe design, which is something very interesting, and what I would say, it asks very pertinent questions on how do you ensure safety inherently in the process itself. So, it goes much deeper than many other techniques that you see here. Now, after so many years, oil companies now started adopting inherent safe design as a prerequisite before they go into the design. So, they are asking designers, prove that you have considered these techniques. Okay. Like for example, if there are end product is there, okay, starting stage end product, the intermediate storage is there. Okay. Now, like in your Bhopal gas tragedy, what happened, your MIC is intermediate product, it is not the end product. Do you agree with me? So, if it is inherently safe design, they would have asked a question that why the hell you want an intermediate stage, right, or it could be one step before it becomes really toxic, correct. So, whatever you produce intermediate stage, then immediately you process, you make it into a safe stage, or you design in such a fashion that you will have only some small quantity, whereby you have very less things to process. In case it releases also, it does not cause problem. I think in the tomorrow I will share with you how a questionnaire on inherent safe design is there. It provokes you lots of thoughts to ask you why it cannot be done. So, the designer before he goes into design has to answer this. Okay. We have some more time, or we need to close? 5 minutes more, okay. Can we just go into the QRA, because this is the most interesting thing, and I will only broadly give the idea, because my subsequent colleagues who are going to come, Arul Arasu and others, will take complete sessions on this. So, we are saying that risk assessment has to be based on the plant. We are saying that level 1 is process radar analysis, it should be done by the plant based people because they understand the risk and possibility how they can be reduced, they may have their views. Then we are saying risk review specialists from process engineering or process safety function at site should include plant based people in the team. Then we are saying enhanced risk review and quantitative risk assessment. So, we are saying that QRA should be done with outside help. Now, out of all the techniques of PHA, QRA is something which has gained a lot of popularity, not because it deals with the numbers or it deals with this thing, it is able to tell the people where exactly you are going to have a problem or how big is the problem is going to be, not where exactly, how big the problem is going to be. Like suppose you have 3000 tons of ammonia, yes, ammonia we know it is a hazardous and it leaks, it can cause kind of thing, but will it cause problem 10 kilometers, will it cause problem at 5 kilometers, will it cause problem at just 10 meters. So, QRA will help you to determine where, how far the problem can do that. So, it also has an interesting feature, like people invest in lot of technology in mitigating the hazard. Say you take the same ammonia tank. Now, one of the ways of knocking down ammonia vapor when it leaks is to have a water curtain, correct. So, if the ammonia vapor is leaking, then if you have a big water curtain around the storage and you start that, then what happens, vapor will contact with water and then some of it can knock down. Okay. Now, there is a risk reduction. Now, whether the risk is coming in the acceptable range or not is something which you want to know, whether one water curtain is okay, 2 water curtains is okay or 3 water curtains are required. How do I determine? So, QRA helps you to understand in numbers how much the risk you are able to break down. Okay. I will give you a simple example. I think you must have heard of a chemical called ammonium nitrate. Okay. Now, ammonium nitrate has got a peculiar property. Okay. It explodes if there is a pressure on it. It explodes if there is a pressure on it. Now, so people do not want it to leak. Now, you have a pipe, ammonium nitrate is flowing through it. Now, you can't say for certain that there will not be leak from the pipeline, yes or no. So, somebody said okay, there is a leak from pipeline and that can cause a problem. So, why not I enclose this pipe in another pipe? Now, what happens, probability wise simultaneously at the same place leak occurring is removed. Yes, it can happen, still happen, through and through it can happen, but in natural phenomena wise at the same place the leak cannot happen. So, at least the risk is reduced as I see by 50%. So, then somebody came with a thought, okay, I will enclose it in one more pipe. But then the finance guys or the cost benefit analysis when you do, you will find that probability wise enclosing it in third pipe is not going to reduce the risk substantially, whereas from first to second yes, but second to third it is not. Okay. For your information, in NASA in your campus you have fire hydrant system, but you have only one fire hydrant system and you assume that when you want it will be available, but in NASA they said, oh, if this fails I have invested some $100 billion in this program, so everything will go wrong, so they have put one more hydrant system. Now, they say probability wise both systems cannot fail simultaneously. So, those are the things that will interestingly will come into QRA, like how much credit I should give, if I have. So, there is no credit for humans because humans are the most unreliable creatures, correct. So, in QRA does not give any credit for humans. Okay. So, that way QRA helps you to do that.
So, what is the solution for this fight?
There is no solution, you have to accept risk. One point I want to tell you in life, there is nothing called zero risk, you have to forget about that.
So, how much percentage of risk
Yeah, we'll come to that. We'll come to that. Hold on. That is where the concept of alap will come into picture. As low as reasonably practical. As low as reasonably practical. Okay. So, some risk you need to accept. Correct? So, you drive a motorcycle or a car or something you drive or a cycle? Yeah, car you drive. So, what is the safety feature? Car can knock down anyone, no? So, what is the safety feature? A brake. So, suppose you argue, a brake can fail, hydraulic system, it can leak, and then I press at the same time, it cannot. But then failure rate is what? Failure rate is what? 1 in maybe 1 lakh or 10 lakh times you press, then it will fail. Correct? It won't fail on every time you press, it fails means that it is not the braking system. Now, for that to avoid, what you are saying, oh, I will have maintenance, I will go for servicing, I will change the oil, I will check the pressure, I will check the interplay. Yes or no? Correct? So, what is happening every time you do any of those things, your probability is changing. As you know that failure rate, it keeps on going up, probability, but the moment you check it, it comes to almost near 0, it is never 0, correct? 0 is again an imagination figure. So, even in case of ammonium nitrate, pipeline over another pipeline is the accepted solution. Now, you may argue, missile can come and hit kind of thing, but how often missile will come? You are not faced war in the last how many years? Ma'am, you are in Chennai, right? So, when did the last war in Chennai happen? 1799. Now, which year we are? 2014. Correct? How many years are over? 215, 216 years are over. So, is it not safe to assume that next 100 years there will not be war here? Correct? Suppose you build bunkers and then all that. See, the last torpedo which hit Chennai was 1913. Okay, that was the one Japanese thing. You near our office still that plaque is there. If you come, you can see. Yeah, are you aware of it? No, in the corner of our office it is there. Yeah. So, and that too it came up to that. That was the last time Madras was evacuated or planned for evacuation and all that. So, it is a one event in 1 in 100 years. But for that, so that is where you have to weigh the risk and then plan accordingly. Yes, you have to plan for cyclones, but not as much as Kakinada or Machilipatnam and all, Orissa kind of thing, Gopalpur and all. Chennai is also in the coast, those are also in the coast, but is the risk is different or not? Yes or no? You agree? Yeah. So, that is where you have to weigh the options and then, so you need not have to build the same number of shelters as that is done in Gopalpur, because here the event is 1 in 1500 years kind of thing. Okay. So, that is where all those things will come in the QRA, which is the most interesting part. So, after this slide we will stop. Identification of hazards and credible accidental events. Okay, I also have to mention to you here, there is an element of subjectivity in all this. I will admit that, but you have to somewhere may have to make assumptions. You can't correctly predict what can go wrong. If we can correctly predict what can go wrong, we are equal to God or whoever it is, right? We have to say this pipeline is there, once in 10 years it will fail, because history tells us, and we also know if you do not maintain because of the operation and other things, it can fail. Then calculation of physical effects of accidental scenarios like vapor cloud explosion, then fires, and then toxic release and all that we will talk about. Damage limits identification mapping on the layout. So, it will tell you 30 meters it will damage or 20 meters it will damage in case of 5 tons of chlorine leaks, how far it will go with this wind speed. You can always argue, no, this wind speed cannot happen. What if it is, I have assumed 1.5 meter per second, what if it is 2.5 meter second. So, this 1.5 meter second is also selected based on the wind pattern. What is the majority wind that is blowing? Winds and all won't change over a period of time. 100 years, 200, it remains same. it remains same. For wind to pattern to change and all, it will take 500 to 1000 years. Anyway, our plant is not built for that long, correct? Any building maximum is 100 years or 150 years. So we are talking about that time span. Individual risk quantification and contour mapping, risk evaluation against risk criteria including worst case scenario, hazard mitigation recommendation. So we will try to broadly say yes, this is the way the hazard can be brought down. But again, as I told you, mentioned to you, yes, it cannot be brought down to 0. It is an approximation. I admit this point. Okay, at this point of time we will take a break, and tomorrow same time we will assemble and then take it forward. I hope the class is interesting. Yeah. Okay. Thank you. Have a safe evening.